This is the second lecture in the FOA series on premises cabling. In this lecture, we'll talk about applications for premises cabling for voice, data, and video. The first applications for premises cabling were for telephones and what we normally call POTS, or plain old telephone service, a system that was basically developed by Alexander Graham Bell over 125 years ago. It uses a pair of wires and it's powered by a current loop from a central source, so no local power at the telephone itself is needed. The nice thing about POT service is you can extend the system as far as you want, up to the limits of the losses on the cable, by simply adding more wire and phones in parallel. Today, more phones are digital. While there's still lots of POTS lines around, most phones use Voice over Internet Protocol, Voice over IP, using computer networks for the voice conversations on the same networks that send data. There are both wired and wireless options. The wired options plug into an Ethernet port or a port in a computer, and the wireless options use Wi-Fi. Many homes and offices still have the legacy cabling installed many years ago for telephones. In the home, there were two wires needed for any phone, so phones typically used 2 to 4 wire systems for 1 or 2 lines. Now, Category 3 is typically required by the FCC in all homes. In an office, often it was legacy multi-pair cables, 25 or 50 pair cables, used for a phone backbone and or a 4-pair unshielded twisted pair cable to the desktop. Computer networks came into widespread use with the proliferation of PCs. They allowed communications among computers for email, file sharing, or internet access. Typically in a premises system, we have what we call a local area network, or LAN. But there are metropolitan area networks that work in cities and wide area networks like the internet or the worldwide telephone system. Essentially, all computers are networked and are used as communications devices. Computer networks have two aspects: a physical connection on hardware, which can be either wired or wireless, and includes electrical and mechanical specifications, and software, which includes the protocol of the network, how data is encoded, addressed, how file sharing and locking works, and how printer and other hardware sharing operates. That's all part of the network operating system in software. Closed-circuit TV is typically used for security applications. It's traditionally used coaxial cable for short links, and now many systems use fiber for longer ones, like in airports or large public buildings. Some cameras are also designed to operate over short, unshielded twisted pair links within the 100-meter limitation of structured cabling. Multiple cameras can be multiplexed by switches and used for monitoring many places around a public building. Practically every kind of communications media has been used for networks, including our typical unshielded twisted pair cables of today, shielded twisted pair cables, or screen twisted pair cables, which are both used to reduce the amount of interference between the pairs or between adjacent cables. Coaxial cables, optical fiber, radio waves, which is very popular now as wireless, but even infrared light and signals sent through power lines have been used for network connections. Today, many desktops are cabled with Cat5 or some type of UTP cable, and most backbones in large corporate networks are fiber optics. However, most users now want mobility for their Wi-Fi laptops and other portable devices. Most networks today are based on Ethernet, a network protocol that looks for devices transmitting on the network, and if the network is not busy, the device can go ahead and transmit its data. It started many years ago in a large coaxial cable, like cable television cable, using what we call a bus structure and special taps, called a vampire tap, that looks like the device in the upper left-hand corner of the slide. Now it works on a star architecture with hubs and switches, using unshielded twisted pair cable, fiber optic cable, or wireless connections. On UTP cable, it's called 10 base T or up to 10G base T on UTP. All these applications work on a fairly standardized network architecture, which we call structured cabling, which has a computer room connecting on backbone cables to telecom closets in remote locations, which then connects to desktops or to wireless access points over what we call horizontal cabling. As an alternative, it may use centralized fiber optics that go straight from the computer room to the work area or the wireless access point. Most people think of structured cabling, they think of unshielded twisted pair. It's a 4-pair cable where each pair has a slightly different twist to reduce crosstalk and uses a modular 8-pin connector assembly in a plug and jack configuration that's usually called an RJ45, although an RJ45 is actually a particular pin-out configuration of this modular 8-pin connector. If there are interconnections, they may be done on patch panels or they may be done on punch-down blocks, like the 66 block on the lower left or the 110 block on the lower right. Structured cabling systems can either use multi-mode fiber in the backbone or the horizontal, or single-mode fiber in the backbones only. The desktop and wireless access point connections are generally done on multi-mode fiber. Most backbones today, more than 70%, are multi-mode fiber, with single-mode fiber being used for long backbone runs like campuses. Most connections are done with either SC connectors, shown on the top, the beige connector, or LCs, the smaller connector shown in blue below. Today, most users like to have mobility, and mobility means wireless. Their laptops, tablet computers, and even their cell phones will connect up to Wi-Fi. But wireless is not wireless. It merely uses an access point connection to the device, replacing a patch cord. So all the access points have to be wired either with UTP or fiber optics into the normal local area network backbone. Cellular phone antennas are also used indoors often, and those typically use either fiber optics or coax to connect to. This lecture series on premises cabling is brought to you by the FOA. If you want more information, refer to our textbooks or our online reference guide at the FOA website, www.thefoa.org.